Real analysis P2 reviews functions. They connect nearly every later definition. So naturally the terminology contains several opportunities to confuse two different sets. A function from x to y assigns each element of x exactly one element of y. Each legal input must receive an output, and it may not receive two different outputs. Different inputs are allowed to share an output. The phrase exactly one applies separately to each input. It does not demand exclusive ownership of an output. Formally, the graph of a function is a subset of the Cartesian product x times y, with exactly one ordered pair beginning with each element of x. The exclamation mark after the existence symbol means unique. It expresses existence and uniqueness together. Because mathematicians eventually become impatient with writing two sentences. There are two basic ways to fail. An input may have no output, or one input may have multiple outputs. Either failure disqualifies the relation from being a function on that domain. The notation f from x to y declares the source and target sets. The notation x maps to f of x describes the assignment rule. And y equals f of x names the resulting output. The domain is the set of permitted inputs. The codomain is the declared target set. The range is the set of outputs that the function actually attains. The range is always a subset of the codomain, but it need not equal the codomain. The codomain is part of the function's declared data, not a prediction that every target will be used. Consider f from the real numbers to the real numbers, defined by f of x equals x squared. Its domain and codomain are both the real numbers, but its range is the non-negative real numbers. Negative numbers remain in the codomain even though none occurs as an output. The function was allowed to aim at a larger target and then miss half of it with impressive consistency. Now define G by the same formula and the same domain, but use the non-negative real numbers as the codomain. The pointwise rule is unchanged, yet the function's codomain has changed. Consequently, G reaches its entire codomain while f does not. A formula alone does not completely specify a function when the domain or codomain matters. The image of an input x is its output f of x. More generally, the image of a subset S of the domain is the set of outputs produced by elements of S. For the squaring function, the image of the interval from -2 to 1 is the interval from 0 to 4. Folding the negative and positive parts together does not create duplicate set elements. The range is simply the image of the entire domain. So range equals f of x. One concept has acquired two names because mathematics was apparently running below its ambiguity. Quota. The preimage of a subset T of the codomain consists of every input whose output lies in T. It moves a set of targets backward to a set of inputs. For the squaring function, the preimage of the interval from 1 to 4 is the union of the intervals from -2 to -1 and from 1 to 2. The notation f inverse of T for a preimage does not claim that f has an inverse function. For example, the squaring function has two inputs mapping to 4. But its preimage of the singleton 4 is perfectly well defined. Images travel forward from subsets of the domain to subsets of the codomain. Preimages travel backward from subsets of the codomain to subsets of the domain. No bijection is required for either operation. A function is injective, or one-to-one, if equal outputs can come only from equal inputs. Equivalently, distinct inputs always produce distinct outputs. An injective function may leave elements of the codomain unused. It merely forbids collisions among the arrows that do arrive. The function 2x plus 1 on the real numbers is injective. Squaring on the real numbers is not, because -2 and 2 are distinct inputs with the same output 4. A function is surjective, or onto, if every element of the codomain is the output of at least one input. In other words, its range equals its codomain. A surjective function may send several inputs to the same output. Every target needs at least one arrow. But the targets are permitted to collect extras. Squaring from the real numbers to the real numbers is not surjective. Squaring from the real numbers to the non-negative real numbers is surjective. Same formula. Different declared target. Different answer. A function is bijective if it is both injective and surjective. Every element of the codomain is hit by exactly one element of the domain. A bijection pairs the two sets perfectly and therefore has an inverse function. The inverse sends each output back to its unique input, with no committee meeting required. When f is bijective, f inverse is an actual function from y to x. This is stronger than preimage notation. Now each individual output has one and only one input to return to. To summarize, the domain supplies inputs, the codomain declares possible targets, and the range records attained outputs. Images move sets forward, while preimages pull sets backward. Injective means no collisions, surjective means no missed targets, and bijective means neither problem occurs. These words are merely arrow bookkeeping, although textbooks occasionally present them as a personality test.